today we have been given this statement that we need to prove. So before we move forward, let me just observe that these gaps, the differences between the denominators of alternating term is always 6. So take this, if there is nothing in the denominator, then there means there is 1. So the difference is 6 from that to this. Again, from that to this is also 6. And if you consider the alternating terms, then also you get a difference of 6. That is just an initial observation. So take these two geometric series for which the common ratio is x to the power 6. So this should be equal to 1 over 1 minus x to the power 6, and this should be equal to x to the power 4 over 1 minus x to the power 6 if x square is less than 1. So the modulus of x is less than 1. Then this series converges to this and that series converges to this. Then what will this expression equal to on the right hand side? It will be equal to this. If we integrate both sides with respect to x, then what do you have? Zero to 1, and let it be 0 to 1. What we have here is 1 minus x to the power 4 divided by 1 minus x to the power 6. Integration runs from 0 to 1 with respect to x, and this is also going to be the same thing. Now, because of the shortage of space, I am going to erase this top portion and move these two lines on there. Now, for a little while, let us focus on the left hand side of this. If you factorize both the numerators and denominators, you should get this. If you cancel out these terms, then you are left with this. So we have taken x square common and divided it on the denominator side. We get this, and if we further manipulate this, we should get something like, let us assume z is equal to this, therefore dz equals, after the partial differentiation we get this. And what will be that, how will the boundaries change? The boundaries will change when x is 0, z is negative infinity, and when x is 1, z is 0. So this is actually going to be negative infinity to 0 dz by z square plus 3. Let me write it here for the shortage of space. It should be something like this, where z runs from negative infinity to 0. This is the formula that we have used here, and here C is the integral constant, but we are doing definite integration, so we don't need the integral constant right now. That is going to be equal to the right hand side of the original expression, because what is tan inverse 0? That is 0. So we are left with negative tan inverse negative infinity. So that is negative of negative pi by 2, which is pi by 2, and there was 1 over root 3 here. So we are getting this. So we may write this is equal to, because the left hand side equals this. So what is the left hand side? So what is the right hand side going to be? The right hand side is going to be, so if we put in 1 in place of x, we get our original expression. After that comes 13, thereafter comes 7, and so on. So that should be equal to, hence proved. Because the 0 is 0 all over, so it was pretty easy to calculate once you know this trick. Otherwise it could be very difficult. So I advise that you watch it again if you find something little bit difficult to comprehend, and then if you still find it difficult to understand, write in the comment sections. I shall try to clarify.